So hey there, everyone. Thank you for attending our session here on the last day of Data and AI Summit. So Avi and I are going to spend the next 40 minutes here exploring ways for you to monetize your data assets by sharing data sets, sharing data science features, and sharing data science models, all using the Lakehouse platform. So let's kick things off with some introductions. So what's cool about our session today is that this is a collaboration between Hitachi Solutions and Databricks. So my name's Keith Anderson. I'm a solution principal at Hitachi Solutions, and I work in our data and analytics practice doing both delivery and pre-sales. And I build lakehouses in Azure Databricks. So I work with our clients to solve their data problems and build out use cases in Lakehouse. Hand it over to Avi for an intro.
Thanks, Keith. I'm Avi Sooriyarachchi. I'm a solutions architect here at Databricks. I've been here for close to 2 years, and I focus mostly on machine learning-related things, particularly in the retail and CPG vertical. As of late, my interests have been along the lines of multimodal machine learning-based systems and machine learning inference in stream. So happy to be sharing what I know with you in this talk.
Great, thanks. So now you know what Avi does, you know what I do. Everyone here knows what Databricks does. I just wanted to briefly talk about what Hitachi Solutions does before we get started. So you may be familiar with the name Hitachi. If you've been in IT, you've probably heard of Hitachi Vantara, Hitachi Data Systems, or even seen the Hitachi name on some industrial or healthcare equipment. So Hitachi Limited is a conglomerate based out of Japan that operates across a number of different industries, including consulting. And Hitachi Solutions, where I work, is a subsidiary of Hitachi Limited, and we're a business and IT consulting firm, and we're part of the larger Hitachi group. So we specialize in industry solutions and work on a lot of ERP, CRM projects. I do a lot of work in the data and analytics practice. We also build modern apps and do cloud infrastructure consulting projects. So at Hitachi, we love Databricks. We're a really good, strong Microsoft partner, and we can help you modernize your data platform and get you into an Azure Lakehouse. So let's get started and talk about the opportunities that exist in monetizing your data and data science assets. So 10 years ago, when Hadoop was popular, we were all at conferences talking about how data sets were exploding, how big data was a massive opportunity since Hadoop was able to process and store big data that wasn't popular, or that wasn't possible with proprietary or legacy platforms. So now in 2023, according to this market research firm, and you probably see in many others, the market for AI now is exploding. According to this study, $87 billion in 2022, and this is estimated to grow to over $400 billion in a couple of years. So why is this happening? What's the driver? It's a couple things. One is the advances in deep learning and GPU hardware. The second is just kind of a continuation of big data. And last is honestly better cloud data platforms that will help you, wrangle, process, and store your data, and also bring your data science to the data using this GPU hardware that's hosted in the cloud. So you don't have to be an AI startup to take part in this opportunity. If you've got domain expertise on your team, if you've got data science expertise on your team, you have differentiated data sets, and you have a good data platform in the cloud, you can also monetize your assets, especially if you're in the Lakehouse. So we're living through a pretty interesting shift with the explosion of generative AI and with the introduction of models like Stable Diffusion, ChatGPT. And what we're seeing is that the industry is shifting from traditional data sharing and sharing of data sets to providing higher value services behind APIs. So companies like OpenAI host some pretty amazing models, and these are monetized. They do this in a variety of ways, but in general, they're behind APIs or a lightweight text input application. So we aren't just talking about sharing data sets anymore. We're seeing the market shift from just sharing data to providing a higher abstraction layer on top of APIs and commercializing things like content generation using subscriptions and API endpoints. So if you're wondering whether your data and your data science assets are really something that have potential value, think about it in terms of a data value chain. So basically, we have a flow of data that increases in value as we go from left to right on this diagram, and we incrementally do more work on the data. So you'll start out with your data engineering teams bringing in data sources, hopefully bring this into a lakehouse, and in the lakehouse, your data engineering teams will clean this data, join it with other data sets, and productionalize those pipelines, and then hand it off to analysts or even to your data science teams. So once the data science teams jump into Lakehouse and start exploring the data, they'll typically start out with feature engineering so that they can get better performance out of their models. And then they'll start training models and trying to recognize patterns in the data, trying to make predictions on data that the models haven't seen yet, and then deploy these models into production. This can be deployed behind APIs or embedded inside of software applications, but usually that's the endpoint, right? So you deploy a model to production and kind of maintain it. But the point of our talk today is why stop there? We should look at monetizing those assets, either with partners or with potential customers to generate new revenue streams. We've done all this work and we've built all this value from our raw data. We can share this out by sharing just the data sets or sharing the features or sharing even our data science models. So first things first, let's look at sharing data sets. Let's just run through how that works in the cloud ecosystem and then talk a little bit about the Databricks marketplace. So sharing data sounds easy. You may think of sharing data as just moving CSV files around or setting up an FTP server. This is okay, but it's not scalable. It's better to have this integrated within your cloud data platform because you really want to have your tool sets and you want to work with that data within the platform rather than trying to ingest it as just flat files. So cloud data marketplaces solve this problem. So they integrate data sets directly into your tool sets and into your platforms already using cloud storage. So you can immediately import data from a marketplace and start working on it, either with your data engineering tools or with your data science tools. So the marketplaces have a couple different concepts. One is just free data sets or open data sets. And the others are ways to either set up a private exchange or even sell your data sets to potential customers. And Databricks is no different. There's a Databricks marketplace now for buying and selling data, as well as getting access to free data sets. So the differentiated thing about the Databricks marketplace is that you can share your Delta data and your Delta tables directly through the marketplace, either for free or through a private exchange or with a subscription model. And this is really useful, especially if you've got data in Delta already. You can share it where it resides securely with partners or with potential customers. So if you're a Databricks user and you've got data in Delta, you've got the opportunity to start monetizing these data sets. And all you need to do to monetize this is first have data in Delta, which is pretty common. That's the default of the Lakehouse in Databricks. And the other is to use Unity Catalog as your meta store. And the last thing is just to sign up as a provider in the marketplace. So through the marketplace, just to recap, you can share data freely with the world. You can create a private exchange and approve lists of folks who have access to the data that you set up privately, or you can sell data on the marketplace once you become a provider or a Databricks partner. So I'm going to jump into a demo and switch screens. So I'm in the Databricks marketplace now, and I have the default view here as a consumer. So this is me going into the marketplace and kind of browsing data sets. So I can browse by provider and pick providers. I can look at different categories, or I can also browse through data sets and look for free data sets. And if I see one I like, I can come in and get instant access, agree to the terms of service, and this is immediately integrated into my workspace with all the tooling that I prefer to use. So going into the Data Explorer, again, this is Unity Catalog behind the scenes, all the data sets that I sign up for are immediately integrated into my workspace. So Avi and I are going to be working with a data set from John Snow Labs, and this data set contains information about mobile food trucks in the city of San Francisco. So if we come in and look at the tables provided by this free data set, we can see there's permits for food trucks, there's a schedule for food trucks, and we can browse some sample data. We can look at the metadata about this data set and see that this is provided through the marketplace using Delta sharing behind the scenes. And this is a table that has been shared out by John Snow Labs as a free and open data set through the marketplace. Now that is a view of the marketplace as a consumer. If you want to become a provider, you can click and go in to become a data provider. And again, this is just an overview, but you can come in and sign up as a partner, become a provider of data, provide it out to the world for free, set up an exchange where you approve customers who can come in or partners that can come in and consume the data sets that you're sharing, or even set up a subscription model and sell your data sets on the marketplace. So that's data sharing. I'm going to jump back into the presentation and hand it over to Avi to talk about building data science features and sharing those as well. And I think, there we go. Okay.
All right, thanks, Keith. I'm glad the notes are kind of clean. Otherwise, it would have been kind of embarrassing. But anyway, so Keith talked about what okay. We're having some screen trouble. Oh, no. Okay, again, thankful that the notes are clean, but present a view. Okay, great. So we talked about sharing data, but sharing features is really, from the mechanics of it, it's not that different. The idea of features is direct inputs to machine learning models. So before I go into all the aspects of feature engineering and whatnot, I want to kind of double click what Keith said at the beginning, is that as you move from data to features, to models, to embeddings, we'll kind of describe all these things as we go, and I'm pretty sure you guys probably know a lot of what these things are, obviously data. We increase the value that you provide to the recipient almost exponentially, but the amount of effort that you put in might only increase linearly depending on the amount of domain knowledge and the data science or machine learning capabilities that you might have. So it's just depending on what you have as an organization, particularly when it comes to domain knowledge, because the technology is kind of becoming commoditized, you have an opportunity to get an unfair advantage, if you will, because not everybody understands this one very specific thing in retail or CPG or healthcare, and having that kind of knowledge will allow you to commercialize the assets that you develop from the data in a way that results in pretty good commercial potential. Now, going into features, when it comes to the features, is probably the most overloaded word in tech. But features in this context is just a direct inputs to machine learning models, and in most cases, this is just tabular data. So the way it usually works out is that you have various data sources. Think of them as sources that kind of emit raw data. And this data can belong to multiple modalities. It could be numeric, text, video, image, all that you can imagine. And you have to convert it to a format that could be made sense of by a model, both during training and inference. Inference is scoring or generating predictions. And although feature sharing, so feature engineering in this case is the process of transforming that data from the raw data to the direct inputs to machine learning models. And although this sounds like a fancy new thing, like sharing features, a lot of well-known companies have been doing this for a long time, because if there's some pre-processing that has been done that would make it more consumable to a downstream analytics process, for example, machine learning or any other thing, it's very similar to a feature data set that you can share. And the mechanics of sharing this is just like sharing any other Delta table, because it's just tabular data, and you can use Delta sharing to do this. And although we kind of framed it up in the context of Databricks Lakehouse, Delta sharing is an open source protocol. Delta is again an open source protocol built based on Parquet. So all this could be done without Databricks, but it's a whole lot nicer to do it within Databricks, because all this stuff is right here, and everybody who starts doing this after we did, use this as a model. But getting back to the sharing my notes part. Oh, great. This is nicer. So we're in Databricks, and we can go to the first notebook. You can see it. Awesome. And all this code is going to be made available to you. It'll be nice to kind of go through this. But the idea is that Keith and I got these tables from the Databricks marketplace, courtesy of John Snow Labs, and they were very generous in sharing these data sets for free. And the idea is to build a predictive model to figure out which kind of truck is best based on a number of combinations. So we're building a simple classifier. Now, we have several tables that we find interesting, and we want to join these things to an analytical base table, which is an old school term, but the idea is that you want it to, like in one single tabular format, then you do your transformations, then you train the model, then you can generate predictions. Now, if you look at what we do here, I don't want to waste your time going through all the fantastic code I wrote, which was generated by Databricks AutoML. Again, we're just spitting out open source code, but the feature engineering code is pretty straightforward, right? So we explored the data, then we kind of figure out how we should join the tables, etc. Then we look at then we figure out which ones we should drop, which columns don't make any sense, add noise to the machine learning process downstream. I mean, machine learning, as Judea Pearl puts it, machine learning is essentially curve fitting. A lot of people won't like that because it's generative AI and it's supposed to be cool. But the idea is that you're extracting signals from the data, and we're kind of like aiding the process along the way. Now, once we have this figured out, we create a catalog and schema, because in the context of Unity Catalog, we have this high-level construct of a catalog. Then we have various schema. Then within those, we have tables, right? And I want to make sure that all this stuff is stored in a single logical construct that we can easily access. So I create a catalog called Data and AI Summit 23 Data Sharing. And I use that, and I create this schema or database. And I save the join table as food truck ML table. I should have probably taken been more eloquent in coming up with the name, but that is what it is. Then I, again, do I look at some of these columns, and I realize there are too many kinds of different food truck types. There was 124 odd food truck types. Then we kind of whittle it down to certain types that make sense, that would make the cardinality of that variable or field smaller. So this is like basic machine learning stuff. Then I do some one-hot encoding, etc. And ultimately, I want to create these features, and I am persisting this table as a delta table in that database in that catalog. Now, when I say database in Databricks, it's not like some relational database system. It's a logical construct that would allow you to kind of organize things better. Now, you have these food truck features that we're going to feed into training a machine learning model, which is just a logistic regression model. The first part of this talk, the machine learning stuff, is not going to be stellar, but if we can solve it with a logistic regression model, you probably should solve it with a logistic regression model. If you can solve it with a select statement, that's probably the best kind of machine learning there is. Now, once we're done with this, then we can take a look at our Data Explorer, and we can go here and take a look at this, whoops, wrong table. Data sharing, and you see this table that I created, and parts from the subsequent demos have already been added. The tables have been added. Now, just assume that this already exists. Now let's move on to the next part. Okay, so we're done with feature engineering, and I showed you what the process of creating those features is, and I think it's convenient to kind of show the sharing part all at once because it doesn't make any sense to go back and forth. Now, sharing models. Now, this is a bit nuanced, and admittedly, this is a much less explored facet of this talk, like commercially at this point, because before I get into that, let's just establish what models are here. We're talking about just machine learning models. We're not talking about data models and things of that nature. Think of them as statistical learning algorithms which have a certain number of weights, and these weights have been iteratively optimized by exposing it to data, right? And of course, if you could consider a linear regression to be a machine learning algorithm, because most textbooks start at that. That has a closed form solution. You don't need to do this whole song and dance. But in most cases, even a support vector classifier, you have to do this iterative process. Now, once you have a trained model, you feed in the features, you do the training. Now you have a trained model, you can do it for two things. Generating predictions, even generative AI models, all you're doing is predicting the next token in a bunch of different ways. So either you have a classifier or a regressor, you can have these reinforcement learning models that produce actions, not certain concrete outputs, but the idea is that you use it to predict. Another thing that has been useful as of late is using a machine learning model to create embeddings. And we'll get to what embeddings are in a minute, but the idea is that machine learning models, if trained properly with the right business context in mind, is super useful. Now, Keith briefly mentioned OpenAI. There's, I think, a whole industry of model-based services that serve their own models. The most common way of serving a model, Azure Cognitive Services before, OpenAI and Amazon with their own like recognition, et cetera, and of course Google. The pattern for monetizing models has so far just been exposing an API, and it's a very clever way because you just don't share the IP, you just expose an API. Usually, like with Databricks model serving, you have a horizontally scaling backend infrastructure that can handle the varying load as if it's a widely used REST endpoint or a service. But in some industries, they might not even want to share your data in that API request. So in that situation, you might have to share the model artifact. So again, I'm not saying that you should share your model because APIs are old school. That's very much not the case. But in certain cases, we have to look at ways of sharing the model itself. Again, it depends on the context. Now, yesterday, it was announced that models are available as shareable assets in the marketplace, and you can use Databricks to do that. Today, we are going to talk about kind of under the hood, less elegant stuff because it's fun to show. And also because this talk was planned before that was announced, so we want to make sure that we didn't end up announcing something that was meant to be confidential. The most conventional way of sharing large models so far has been sharing them in object storage. So you just get you use your own credentials to generate a pre-signed URL, and you share that URL with some, the recipient, and they can use that to access the model for a defined period of time. And of course, this is not something that you do like if you're a commercial entity trying to monetize your model by sharing your model weight, so the model itself, that is. You do this in a way that's that you probably want to build a service around it. But the way that I'm going to show you right now is a bit more nuanced, and it's admittedly a bit hacky. So let me explain. All right. So as I mentioned, this is nothing fancy. Again, I'm an engineer by training, so I'm lazy. So I just use AutoML. I just fed the feature table that I got into AutoML, used it to generate the notebooks, and turns out a logistic regression model is the model that it produced. So this is a picture of the model pipeline. I don't want to bore you with the code, and the code is available in the repo that'll be shared with you at the end of the talk. Now, the way we did it, is, within Databricks, in MLflow, which is an open source project that has been very successful in the MLOps space, it's tightly integrated to the machine learning runtime. So whatever model that we train is going to be automatically logged and tracked with MLflow. So what we did was we registered the model. You can do this with the UI or the Python client. And you can use the client to retrieve the pickle file that contains the model itself and all the related assets, to do whatever you want to do. We convert that into a base64 encoded string. So this is the part that's hacky. Then we read into a Spark data frame and wrote that as a delta table. Then you got a delta table that you can share using delta sharing. Now, what happens if the model is big? Then things get interesting, right? Because then you might have a very, very long string. So in a lot of cases, it makes sense to use out-of-the-box service like Databricks model sharing, which has taken all these considerations into account, or just go with the pre-signed URL and build a service around it. Now, the way that this is done in code, you use the client to extract the artifact, the MLflow Python client. Then you can kind of see that it's saved to a temporary folder. Then you specify a storage directory for all these things. Then you move them to that storage directory. Then you pickle it. Pickling is like kind of the Swiss phenomenon. I mean, it's kind of like a very brute force way of like serializing things, but it's probably the most useful thing in this case. Then you can convert this into a base64 encoded string, which ends up in a table as I described. And I only printed the first 50 characters of it. The rest of it looks just as ugly. But you can create a table with it, and you can share the table. You can persist the table to the same location as before. And here, that's why you see as the encoded model. So if I go here and look at the sample data, it doesn't look pretty. But then you can share this table with delta sharing. Do I recommend this? No, use Databricks model sharing. But is it a cool way to do stuff? Yeah, it's worth giving it a try. Now, moving on to the next one. So embeddings, honestly, personally for me, is the most interesting part of this talk. And I think a lot of you guys left. I'm just kidding. It's going to be, it's a new way of looking at things. So if you look at the OpenAI OpenAI or Cohere or any of these model services, the pricing page, and compare the pricing for the predictions versus the embeddings themselves, it's an order of magnitude more expensive for the embeddings. Now why and what are embeddings? Again, this is a data and AI conference. You guys probably know what this is, but I think it's worth establishing. Of course, this. Awesome, thank you. And the idea is that embeddings are a compressed numeric representation of data that captures meaning. So whether the data that you that you embed is unstructured, numeric, or multimodal. So if you've been following the machine learning news where you have something exciting happening every 2 days, Meta released something called ImageBind, which allows you to map multiple modalities of unstructured data to a single embedding space. So you have basically a list or a list of lists that captures the meaning of all aspects of a dog, all aspects of a product, or all aspects of a person. Now imagine being able to generate an embedding like that and sharing and monetizing that. So for example, if you fine-tune a model, a large language model or a foundation model that works across modalities and encode information about a certain group of people or products and share these embeddings, then those embeddings captures so much information that could be used for analysis. Again, this sounds very abstract, and that's kind of why I want to spend more time than usual talking about what this looks like in reality. Anyway, once you have these embeddings, you can use it for many downstream applications. For example, you can use embeddings for classification, clustering, recommendations, and things of that nature. So if I were to change my screen and go to the embeddings part. So the idea is that, again, this is what's going to be a 5-minute demo, and I want to show what this looks like, what it's like to generate embeddings, and what the process of sharing it is. And disclaimer: it's ultimately you're going to end up sharing a table, but you can use something called setFit to fine-tune a encoder model and regenerate the embeddings of reviews about these food trucks. So imagine that you have positive, negative, neutral embeddings. Reviews about this food truck, for example. Scott was great. I'm sure he was a great server, etc. And some food was probably not good. You have these like different reviews. Now you can use this sentence transform model to generate the embeddings for each piece of text. And once you generate these embeddings and map it to a lower dimensional space, say with 3 principal components, now you see how these embeddings are kind of clumped together, although they're positive and negative, right? So for example, best pho in town, period. That's awesome. Now you have something that's not so great, but it's all clumped together. So if you look at this, there's some, separation because this is a pre-trained language model. So it has some notion of language, but you haven't optimized the model to separate out, good and bad reviews. So what we do is we use something called setFit to create a classification model, but in the process, what you're doing is really fine-tuning the encoder. And the code is available for you to check out, but if you go to the visualization, now you see a better separation. And I spent literally like half a minute like fine-tuning this encoder and only a handful of samples because I had to finish this demo this morning. And you see this clear separation, right? Now imagine like instead of like, food reviews that nobody cares about, what if it was about like certain demographics or certain products, and you are a data vendor that's commercializing these embeddings, and you assume that your recipient is a grocery store chain or some retailer, and think about like how this information could be advantageous to you in interpreting, using them for building downstream models for, building recommenders or understanding, how people behave in general. So this is probably in my opinion, the most lasting and kind of like rich way of monetizing data. And again, it really depends on your context. Now, the process of sharing this is just a table because you can just flatten out the list, right? A list of lists, because embeddings, the physical manifestation of an embedding is just a list of lists, just floats, and you can flatten it out and just share it like a table, as a delta table, as a matter of fact. So the other thing that you're going to take away from this talk, hopefully, is that delta is a pretty versatile format, and you can stick anything in there and share it. But TLDR, so we showed you how to store a model, features, data, and embeddings as delta tables, but I haven't shown you anything about sharing the models, using delta sharing. Now, if we go to delta sharing, I can see this thing called Data and AI Summit Data Share, and I see these tables that were, that I wanted to share in this share, but I didn't show you how to kind of create it. So let's go back and actually create a share. So there's on the spot. You can add a comment. I just don't think I have enough time. Then you can add recipients. For example, I can add Keith, who has a Databricks account tied to Hitachi Solutions. Or I can add one of you who probably doesn't have a Databricks account, and you might be using Power BI or just Pandas. And I can add you as an external consumer, and you don't have to be a Databricks customer to do this, to receive it. Then I can say add tables. I can do data sharing, DB. I can add all these things, right? These are the ones that we just saw. I can save it. And another thing that's important is that I am sharing a pickle file of a model. Now like if I communicate via email that, hey, this is a notebook that you can use to decode this and load it into whatever wrapper that you want, that'll be nice. But the idea is that you want it to be self-contained. You want an elegant means of transmitting code as well while you share data. So I can add a notebook file, and I can kind of find a notebook that is relevant and share with the recipient. So for example, if I go here, just to save time, data share, you can see this notebook that was added so that they could decode the pickled model. So that notebook looks exactly like this, just in the interest of saving time. So you can just unpickle.loads and extract the right object. You have a scikit-learn pipeline. This code is available to you for you to try out, just 4 notebooks that works through the entire process from a kind of a coding from a programmatic perspective. I'll leave it. I'll hand it to Keith to talk about the summary of it.
Yeah. So we saw how in Lakehouse you can share data sets in a data marketplace, either for free or selling and monetizing your data sets. You can build data science features and basically store them as tables and share them the same way. You can train models and kind of share the pickled files the way Avi showed, or kind of look at some of the new features in Delta sharing that are available. And then last, kind of the highest value and the most work is probably sharing more advanced things like embeddings, and those probably have the most opportunity for monetization, just because it requires more expertise and more SMEs, either from your domain or from your data science team. Those are the ways, and they're all available within Lakehouse, and that's kind of our preferred way of building data science platforms, both in Databricks and with Hitachi solutions. So thank you, everyone.